Have you ever sat under the night sky and wondered if Earth is the only Goldilocks planet? Picture this, a far-off world, orbiting a star just like our sun, where conditions are just right for life as we know it. This is the essence of a Goldilocks planet, named after the storybook character who preferred things not too hot, not too cold, but just right. These celestial bodies exist in a habitable zone, an area around a star where conditions might be perfectly suited for life. But how many of these Goldilocks planets are out there? There's an ongoing debate among scientists about the prevalence of such planets in the universe. The rare Earth hypothesis suggests that Earth's conditions for fostering complex life are unique, while critics argue that Earth may not be as exceptional as proposed. As we continue our cosmic journey, we're left pondering a fundamental question. The question remains, is Earth truly unique, or are there more Goldilocks planets out there? You might have heard about the rare Earth hypothesis, but what does it imply? Imagine the universe as an infinite jewelry box filled with countless celestial gems. Among them we find Earth, a dazzling sapphire spinning around a golden sun. The rare Earth hypothesis takes this metaphor a step further, proposing that Earth is no ordinary gem, but an extraordinary one, with a unique set of conditions that have allowed complex life to flourish. This hypothesis puts forth several key factors that make Earth so special. First off, our star system's stability. The Sun, our celestial lantern, provides just the right amount of heat and light, maintaining a consistent rhythm without any drastic changes. This stability is crucial for life as we know it, allowing for the existence of liquid water and thus the emergence and evolution of life. Next, consider our large moon. It's not just a pretty face in the night sky or a muse for poets and dreamers. The moon plays a vital role in stabilizing Earth's axial tilt, creating a predictable climate and enabling the cycle of seasons. Without it, our planet's tilt would be chaotic, making life as we know it a lot less likely. Lastly, let's not forget Jupiter, our solar system's largest planet. Acting like a celestial bodyguard, Jupiter's massive gravity pulls in and devours most of the space debris that could pose a significant threat to Earth. This protective influence has likely played a crucial role in maintaining Earth's habitability over billions of years. The rare Earth hypothesis suggests that this confluence of factors is not just a happy coincidence, but a unique set of circumstances that make Earth a rare jewel indeed. This hypothesis paints a picture of Earth as a rare jewel in the cosmos. But is it an accurate portrayal? Let's delve deeper into this cosmic conundrum in the next scene. As compelling as the rare Earth hypothesis may be, it's not without its critics. The hypothesis, which suggests that our Earth's conditions fostering complex life are unique, has been met with skepticism. Critics argue that there are limitations in the data used to support this hypothesis. Let's delve into this a bit. The rare Earth hypothesis is largely based on observations of our own solar system. This, critics argue, gives us a rather narrow view. It's like trying to understand the variety of life on Earth by only studying a single forest. We simply don't have enough data from beyond our solar system to make such sweeping statements about the rarity of Earth-like planets. Another point of contention is the assumption about the rarity of certain planetary features. The rare Earth hypothesis places great emphasis on factors like a stable star system, a large moon, and the protective influence of a planet like Jupiter. Critics argue that these factors might not be as rare or as crucial as the hypothesis suggests. For instance, while our large moon does contribute to Earth's stability, it's possible that life could adapt to more variable climates on planets without such a moon. Critics also point out that life on Earth has proven to be incredibly resilient and adaptable. From the deepest ocean trenches to the highest mountain peaks, life has managed to thrive in conditions far from what we'd consider ideal. Who's to say that life elsewhere in the universe couldn't do the same? Furthermore, the rare Earth hypothesis seems to assume that all life requires conditions similar to those on Earth. But what if life elsewhere is based on different biochemistries? What if it thrives in conditions we can't even imagine? These critics suggest that Earth may not be as exceptional as we believe, but how can we find out? Well, the search for Earth-like planets and the possibility of intelligent life elsewhere in the cosmos continue to fuel our curiosity and exploration. It's a thrilling journey of discovery that might just redefine our understanding of life in the universe. The quest for other Earth-like planets is a fascinating journey full of surprises. In this relentless pursuit, our scientists have devised ingenious methods to detect these potentially habitable worlds. The most prolific method is the transit method. It involves observing a distant star and watching for a slight dimming in its light, which could indicate a planet passing in front of it. The fascinating Kepler Space Telescope, launched in 2009, used this method to discover over 2,000 confirmed exoplanets. Then there's the radial velocity method, which allows us to detect the slight wobble of a star caused by the gravitational pull of an orbiting planet. It's a bit like observing a spinning top wobble as a marble orbits around it. These methods have led us to some remarkable discoveries. Take Kepler 22b, for instance. It's an exoplanet about 2.5 times the size of Earth, residing comfortably within the habitable zone of its star. It was the first such planet discovered by the Kepler mission and stands as a testament to our scientific prowess. Or consider Proxima Centauri b, our closest known exoplanet, residing in the habitable zone of the star Proxima Centauri, just over 4 light-years away. It's roughly Earth-sized and could potentially harbor liquid water on its surface. Then, of course, there's the TRAPPIST-1 system, a veritable jackpot of potential Earth-like worlds. This system, about 40 light-years away, boasts 7 Earth-sized planets, 3 of which reside within the star's habitable zone. But the search is far from over. With powerful new tools like the James Webb Space Telescope set to launch, we are on the cusp of a new era in exoplanet discovery. We may soon be able to study the atmospheres of these distant worlds, looking for signs of life as we know it. The discovery of even a single Earth-like planet could change our understanding of the universe. And who knows, maybe one day we'll find a planet that doesn't just look like home, but feels like it too. Finding another Earth is one thing, but what about intelligent life? This is a question that has been on the minds of scientists, philosophers, and curious minds alike for centuries. The possibility of intelligent life emerging elsewhere in the galaxy is not only fascinating, but it's also a key area of exploration and speculation. The universe is vast, with billions upon billions of galaxies, each containing millions, if not billions, of stars. Around these stars, planets orbit, and amongst these planets there may be those that fall within the Goldilocks zone, a habitable range where conditions could be just right for life as we know it. However, the emergence of intelligent life is not simply a matter of being in the right place at the right time. It also requires a certain sequence of events, a precise cocktail of conditions and elements, much like what we experienced on Earth. For instance, the Earth's stable star system, large moon, and the protective influence of Jupiter have all contributed to the conditions necessary for life to flourish. But even with these conditions met, the jump from simple life forms to complex, intelligent beings is a significant one. This leap involves a whole host of factors, from the development of multicellular organisms to the evolution of brains capable of complex thought and self-awareness. It's a process that took billions of years here on Earth, and it's not certain if it could happen elsewhere, even given the same conditions. And yet, the possibility remains. The sheer scale of the universe means that even if the odds are slim, there could still be planets out there where intelligent life has emerged. It's a tantalizing prospect, one that drives our exploration and fuels our curiosity. Whether we are alone or not, the search for life beyond Earth continues to captivate us. Our journey through the cosmos brings us back to the original question: is Earth the only Goldilocks planet? We've delved into the rare Earth hypothesis, heard from its critics, and embarked on a search for Earth-like planets. We've pondered the possibility of intelligent life beyond our world. Yet the universe remains a vast, uncharted territory, and our quest to find other habitable planets continues. The question, thus, remains open. What do you think? Is Earth unique, or are there other Goldilocks planets in the cosmos? Share your thoughts in the comments below. And if you enjoyed this journey, support our channel by subscribing and giving this video a like.